This is question number 40 from book number 1 based on the 2020 NEC, and this is electricaltime.com. A fixed in-place microwave is installed in the kitchen of a dwelling unit. The microwave is cord and plug connected and is 120 volts and 1500 watts. A single receptacle is installed just for this microwave. This dedicated branch circuit will only power up the microwave. What size branch circuit is the minimum that can be installed? Is it 15 amps, 20 amps, 30 amps, or 40 amps? Just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video. And the answer to this question is going to be A, and that's going to be 15 amps. So when we're looking at this question, we're asking ourselves, what article are we talking about here? And we are talking about branch circuits. And branch circuits are found in Article 210, which is also titled Branch Circuits. And that is within Chapter 2, Wiring and Protection. And within Article 210 for branch circuits, we find Part 3, which is called Required Outlets. And within that, we find 210.52, and that is called Dwelling Unit Receptacle Outlets. And then we find 210.52b, which is for small appliances. Then we find 210.52b1, which is for receptacle outlets served. And then we find 210.52b1, exception number 2. And here's where they talk about the specific appliance. All right, so let's do something here. Let's go back into the question. And here's what I would do if I were, taking this exam. I see volts and I see watts. And right away, what I'm going to think of Ohm's law and pi. So I'm going to write that down on my exam. I'm going to write down EIR, and that's going to be for Ohm's law. And then I'm going to write down pi, the pi formula. And now what I'm going to do is I'm going to highlight the information that I know. So I'm being told this is 120 volts. So I know that's going to be the letter E. And I'm being told that we got 1500 watts, and that's going to be P. So when I look at both Ohm's law and P, I know I can solve for I, which is amps. So if I'm going to solve for amps, for pi, it's going to be I is equal to P divided by E. All right, and once I solve I for amps, then I can actually go in and highlight this for Ohm's law. Now I can solve for R, which is for resistance. How cool is that? All right, so let's go back into our textbook. All right, so now let's look at the pi formula, that we just looked at just now. And that's where P is equal to I times E, where P is for the power in watts, I is for amps, and E is going to equal for volts. Now we're going to solve for amps. And just like we just did, I is equal to P divided by E. I is equal to 1500 watts divided by 120 volts. And I is going to equal 12.5 amps. All right, so next step. We're going to take a look at table 310.16. And that tells us that 14 AWG conductor at 60 degrees C can carry 15 amps, which is more than the 12.5 amps required. Therefore, 15 amps is going to be the answer. Again, table 310.16 in the 2017 code book, that was table 310.15b16. In the 2020 code book, it's table 310.16. And I call that the ampacity table. That's the one that I use most of the time. And that's my favorite table. All right, so I also want to make a note here. If the appliance that you are sizing the branch circuit for, if it's going to be considered to be what's called a continuous load, and that's going to be something where the max ampacity is going to be, on for 3 hours or more, you're going to take that ampacity and multiply it by 125%. But since a microwave is going to be on for maybe 1 minute, 2 minutes, 3 minutes, maybe 10, 15 minutes, not a very long duration of time, we're not going to subject this to the continuous load, and we are not going to multiply this by 125%. I mean, we don't have to, but, when I see people using heavier conductors than they have to, that's not a bad thing. That just means that, they're going to have less resistance in those branch circuits. And, there are some electrical contractors that will do the majority of the wiring in a dwelling unit, with 12-2. They won't use 14-2 NM for branch circuits, which are rated for 15 amps. They just like using, 12-2. And if we look at table 310.16 in the 60-degree C column, we're going to see that's going to be good for 20 amps, for 12-2. But, depending on, your budget and, what you're used to doing, I mean, that's certainly that you have a preference. But you cannot go below the minimum standard set by the NEC. All right, so let's see what else we got here in our textbook. Also note that table 310.16, 15 amps is the least amount of amps in this table. And to further reinforce this, take a look at 310.3a, and that's called minimum size of conductors. It says that 14 AWG copper is the minimum size, and which is 15 amps per table 310.16 for copper. If you were wondering why I automatically picked the copper conductor versus the aluminum conductor, it's because I like copper better, and the test writer can pick his or her favorite conductor. Now, I'm just kidding about that. Read 110.5, and that's called conductors. And it says that if the code does not mention the conductor material, then it's going to be copper. And that's just the way it is. So again, if you're reading a question and the test writer does not mention whether it's copper or aluminum, then it's just going to be copper. And the code reference on that is 110.5. That's where you can read that, and you can see what it says in there about that. All right, so the answer to this question is going to be A, and that's 15 amps, and that's code reference 210.52B1, exception 2.